Next concept in microprogram example is symbolic microinstructions. We already know the assembly language microprogram in microprocessor course. Each line of the assembly language microprogram defines a symbolic microinstruction. A symbolic microinstruction can be divided into 5 fields. The first field can be called as label. The second field is micro operation field. The third field is CD field. Fourth field is BR field. Fifth field is address or AD field. Now consider the first one. The label field may be empty or it may specify a symbolic address. Sometimes label field is empty. Sometimes it may contain a symbolic address. A label is terminated with colon. Every label is terminated with colon. For example, this one. Fetch colon. Okay, here fetch is called as label. Each label is terminated with some colon. Sometimes a label field may be empty. Sometimes it may contain this symbolic address. Next, second one is micro operation field. It consists of 1, 2 or 3 symbols that are separated by commas. Okay, there may be chances it may contain 1 symbol or it may contain 2 symbols or it may contain 3 symbols. Okay, that are separated by commas. So micro operation symbols are separated by commas when they are containing 2 symbols or 3 symbols. From each F field we can take 1 symbol at a time. From F1 field we can take 1 symbol. From F2 field we can take 1 symbol. From F3 field we can take 1 symbol. It is not possible to take more than 1 symbol from each field. It is not possible to take 2 symbols from F1 field. It is not possible to take 2 symbols from F2 field. It is not possible to take 2 symbols from the F3 field. Okay, from each and every field we can take 1 symbol at a time. When we are taking 2 symbols from 2 different F fields, then that 2 symbols are separated by comma. Next one, CD field. CD field has one of the 4 letters U, I, S and Z. These are the status bit conditions. U is always conditionally true. I means indirect address bit. S means a sign bit and Z means 0 bit. Okay, so CD field may contain among these 4 symbols. Next one, BR field. BR field contains one of the 4 symbols: jump, call, return and map. Among the 4 symbols, we can take 1 symbol in the BR field. Next one, address field. Address field specify a value for the address field of the micro instruction. Address field always contains the address value. Okay, it may contain in 3 possible ways. First one is with a symbolic address which must also appear as a label. If the address field contains some symbolic address, which may also appear as a label. Okay, so address field can also appear as a label. Next, second one, with the symbol next to designate the next address in sequence. In the address field, suppose next is there. So next determines what is the next address in sequence. That can be defined by using the next symbol. Third one is when the BR field contains either a written or a map symbol, the address field is left empty and is converted into 7 zeros by the assembler. When the address field contains either written symbol, RET symbol or a map symbol, at that time address field is empty. That can be filled with 7 zeros. Okay, so address field may contain some address value. It can be done in 3 possible ways. So first one is symbolic address can also appear as a label. Okay, in the address field, sometimes some symbolic address is also possible that can appear as a label. Second one is in the address field, we have to specify the next symbol. It determines the next address in sequence. Third one is when the BR field contains RET or a map symbol. Okay, at that time we have to put empty space in the address field that can be filled with 7 zeros. Okay, these are the 5 fields in the symbolic micro instruction. While we are writing the symbolic microprogram, compulsory we have to use these 5 fields: label field, micro operation field, CD field, BR field and address field. So micro operation field specifies the micro operation to be performed whenever more than one micro operations are performed at the same time. That can be separated with comma. Okay. Next one is ORG. It defines the origin or address of the first microprogram routine. That means address of the first instruction in the microprogram routine that can be denoted with ORG. Next one, previously we are already see the symbolic micro instruction and its field. Once we know the symbolic micro instruction and its fields, then we have to translate the symbolic micro instruction into symbolic microprogram. How it can be translated? Control memory consists of 128 words. Each word contains 20 bits. Among that 128 words, first 64 words can be used for storing the addresses of 16 micro instructions, and the last 64 words can be used for the fetch routine and other routines. Next one, a convenient and starting location for the fetch routine is address 64. Okay, fetch routine always starts with address 64. What are the micro instructions are required for performing the fetch routine? These are the micro instructions that are used for performing the fetch routine. First one is the content of PC is transferred to AR. PC always contains the address of the instruction to be executed next. That address can be transferred to the address register. Once the address of the instruction is known, that instruction is read from the memory by using this instruction. Here the address register contains the address of the instruction in the memory. Okay, go to that address in the memory. We have to read that instruction. That instruction can be transferred to the DR register. While executing this instruction, PC value is incremented by 1. That means PC points to the next address of the next instruction to be executed. Now the currently executing instruction is available in the DR register. Okay, now the first 11 bits of the DR register can be transferred to the address register, and 11 to 14 bits of the data register can be transferred to 2 to 5 bits of the control address register, and 0, 1 and 6 bits of the control address register is cleared with 0. Okay, so this third micro instruction represents the mapping logic. Okay, second micro instruction represents the reading the instruction from the memory. At the same time, PC value is incremented by 1. The first micro instruction is the address of the instruction is transferred to the address register. Okay, these are the 3 micro instructions that are used for the fetch routine. Next one, we can write we can write the symbolic program for this fetch routine as follows. Okay, so here fetch is the label that can be terminated with colon. Fetch routine always starts with address 64. ORG is nothing but origin. 64 is the address of the starting address. Next one. So first micro instruction is the content of PC is transferred to AR. The source register is PC. Destination register is AR. So in between them we have to write T. So that we have to write first, we have to write the source register. Then we have to write the destination register. In between them we have to write T. Here we do not check any condition, so that CD field contains U and BR field contains jump. Then what is the next instruction to be executed? Address field contains next. Next, this micro instruction can be converted into this symbolic microprogram. We have to read the micro instruction from the memory. For that purpose, we have to read and increment PC by 1. That is nothing but INC PC. We do not check any condition, so that we have to write U in the CD field. So BR field contains a jump and address field contains next. Next, the third micro instruction is we have to transfer the content of data register into AR. Source register is DR and destination register is AR. In between them we have to write T. So DRT AR. Next one is, this is we do not check any condition here. This entire thing is nothing but mapping logic. Okay, so this is the symbolic microprogram for this fetch routine. Then once the symbolic microprogram can be obtained, that can be converted into equivalent binary microprogram. Here this is a label and this is micro operations and this is a CD field and this is a BR field and this is a address field. These are the 5 fields of the symbolic micro instruction. This symbolic microprogram can be converted into equivalent binary microprogram. So here in this one, first column represents the binary addresses and second column represents the F1 micro operation. Third column represents the F2 micro operation. Fourth column represents the F3 micro operation, and this is a CD field, and this is a BR field, and this is a AD field. Fetch routine always starts at address 64. So this is the 64 binary equivalent, 1 6 zeros. Okay, next one at address 64. Okay, what is the first micro operation we have to done? So PCTAR. So PCTAR is nothing but it is available in the F1 field at binary code 110. Okay, then F2 field is empty, so that it can be filled with 3 zeros. F3 field is empty, it can be filled with 3 zeros. Unconditional means CD contains 0 0. Jump means BR field contains 0 0. Then what is the next address? Here the address is 64. What is the next address? 64 plus 1, that is 65. Okay, so in this first row only F1 field contains 110. 110 is nothing but binary code of PCTAR in the F1 table. So previously we have to see the F1 table. In the F1 table, see the 110 binary code. The corresponding micro instruction is PCTAR. Okay. Once F1 is considered, then F2 and F3 are filled with zeros. Now we have to take the 65 binary address. So 1 5 zeros 1. Okay. In that one, we have to read the micro instruction from the memory. At the same time, we have to increment the program counter. 2 micro operations are done that can be separated with a comma. So here, read micro operation is not available in F1 field, so that F1 field is filled with 3 zeros. Read micro operation is available in the F2 field with binary code 100, and INCPC is available in the F3 field at binary code 101. Okay. CD field contains U. U is nothing but 00. BR field contains jump. Jump field is nothing but BR value is 00. Then what is the next address? Here this is a 65. Then what is the next address? That is a 66. Here we have to perform 2 micro operations, so that we are considering read micro operation from F2 table. Its corresponding binary code is 100, and INCPC is available in the F3 field at binary at address binary code 101. So from F2 field we are taking 1 micro operation. From F3 field we are taking 1 micro operation. From F1 field we do not take any micro operations, so that it can be filled with zeros. Next one is now considering 66 address. Here this is 65, the next address is 66. Now consider the 66 address. In that 66 address, we are transferring the data available in the data register into the address register. So DRTAR. DRTAR is available in the F1 table at binary code 101. So there is no micro operation is there, so that F2 field is filled with 3 zeros, F3 field filled with 3 zeros, and CD field contains U. U is nothing but 00. Okay, Next one here, BR field contains map instruction. So BR map instruction corresponding BR value is 1 1. Then so up to now fetch instruction is completed. Then we have to go for next instruction to be fetched, so that it can be filled with 7 zeros. Whenever BR field contains map or RET, then address field can be filled with 7 zeros. It does not perform any operation. That means it can go for the next instruction to be fetched. Okay, so this is the micro instruction for the fetch routine, and this is the symbolic microprogram for the fetch routine, and this is the binary microprogram for the fetch routine. Okay, so in this way we have to take some micro instruction. What is the corresponding symbolic microprogram and what is the corresponding binary microprogram, that can be discussed in the next slide. This is symbolic microprogram for various instructions. In the previous we are seeing the symbolic microprogram for the fetch routine only. In this table we have to write the symbolic microprogram for add microinstruction, branch microinstruction, over microinstruction, store microinstruction, exchange microinstruction, and indirect. Okay, so here add microinstruction starts with the org0. So it is originated with the 0 address. Branch instruction is start with address 64, and store instructions start with address 8. Exchange instructions start with address 12. Now considering add micro instruction, it starts with address 0. First we have to check any indirect address is there. Okay, for that one we do not perform any operation, so that is NOP. CD value is equal to 1. We have to check any indirect address is there. At that time we have to call the subroutine in BR field. Then it can goes to INDRCT. Okay, then it goes to this one INDRCT. So at that time we have to read the effective address from the memory. That can be, once the effective address we are getting, that operand can be transferred into the data register. So we have to go to that indirect address, then we are getting the direct address. From that address we have to read the operand from the memory at a particular address. That address is specified by the address register. Then that content can be transferred to data register. At that time CD contains U, and here also CD contains U. So here CD contains jump. When we are performing the read operation, BR contains the jump. When we are performing the DRTAR, then BR contains return. We are returning from the subroutine to the main program. For that purpose, we have to use a return statement. Then, after reading the operand from the memory, so here, while performing the read operation, CD value is U and BR contains jump. Then what is the next address in sequence? So here we have to add the content of the accumulator and the data register. At that time CD contains U and BR contains jump. Once the add operation is completed, what is the next instruction to be fetched? For that purpose, we have to write the fetch. Okay, so in this way, these are next branch instruction start at address 64. So while performing the branch operation, we do not perform any micro operation so that it can represent MOP. Then CD contains yes. So here we have to check the sign bit value. If the sign bit value is 1, okay, so at that time we have to call the over field. Okay, so BR contains jump field. Then what is over? So over is nothing but, so we do not perform any micro operation here. So then we have to fetch the branch address. We have to fetch the branch address. At that time BR field contains jump. Then here we do not perform any operation. CD contains I, that is any indirect address bit is there. Then we have to call the subroutine. For that purpose we have to use indirect. So indirect address is there. Then again we have to call this one by using the indirect. So then whatever the address that is present in the program counter, that can be transferred to address register. At that time CD contains U, BR contains jump. Once the branch operation is completed, we have to again fetch the next micro instruction. Next one, store micro instruction. It can start with address 8. So we do not perform any operation, micro operation, so that it is MOP. So CD field contains 1. Whenever CD field contains 1, we have to call the subroutine. Whenever we are called the subroutine, we have to use INDR CT. So store instruction is nothing but whatever the content that is present in the data register, that can be stored into the memory at a particular address. So we have to read the content. So whatever the content that is available at address AR, that can be transferred to DR. Then we have to return from the subroutine. So we have written from the subroutine. Then go to this one. Whatever the content is there in the data register, that can be transferred to AC register. So at that time CD contains U and BR contains jump. Then what is the next instruction to be executed? Finally, whatever the content is there, that content is available in the data register. That data register, whatever the content is there in the data register, that can be write into the memory at a particular address. At that time CD contains U, BR contains jump. Once write operation is completed, we have to fetch the next micro instruction. So here the accumulator is not directly connected with the memory, so that we have to use the data register as intermediary. Okay, whatever the content in the accumulator, that can be transferred to the DR register. Whatever the content in the DR register is there, that can be write into the memory at a particular address. Okay, next one is exchange instruction. Exchange instruction starts at address 12. We do not perform any operation. CD field contains 1. So we have to call the subroutine. For that purpose, we have to write indirect. So we have to fetch the data from the indirect address by using these two instructions. Once we are reading the operand from the accumulator and data register, then we have to exchange the data between them. So this is the simple symbolic microprogram. The corresponding binary microprogram can be stated next. This is the binary microprogram for the various instructions that are mentioned in the symbolic microprogram. For the corresponding symbolic microprogram, the equivalent binary microprogram can be converted by using the assembler. Assembler is used for converting the symbolic microprogram into binary microprogram. For each and every micro instruction that is specified in the symbolic microprogram that can be converted into binary microprogram, for add instruction, branch instruction, store instruction, exchange instruction, and fetch instruction. Add instruction starts with 0, branch instruction starts with address 4, store instruction starts with address 8, exchange instruction starts with 12, fetch instruction starts with address 64. The corresponding equivalent binary, and these are the symbolic micro instruction field that can be converted into equivalent binary microprogram. So symbolic micro instruction contains F1, F2, F3 fields, CD field, BR field, and AD field. Okay, so whether we are considering F1, F2, F3, the corresponding binary code is there, otherwise they can be filled with 0. CD value, maybe it may contain 00, 01, 10, 11. BR also contains 00, 10, 11. AD contains 7-bit address field. So this is the simple binary microprogram. So I hope all of you understanding this video. If you really understanding this video, please click on the like button and share this video to your friends and classmates. If you really understanding this video, please subscribe my YouTube channel. So Divvela Srinivasarao. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Thank you one and all for watching this video. So this microprogram contains 3 videos, part 1, part 2, part 3. That while playing part 1 video, part 2, part 3 videos are mentioned in the comment box. While playing part 2 video, part 1, part 3 videos are specified in the comment box. While playing part 3 video, part 1, part 2 videos are specified in the comment box. Please observe this. Thank you one and all for watching this video.